Do you hear about that fucking object that's hurtling towards Earth at like 130,000 miles an hour?
No, that might solve all our problems.
Something wild is going down deep in space. The interstellar visitor known as 3I/Atlas is breaking all the rules. It's shooting out a metal compound that no one's ever seen occur naturally before. We're talking about a refined alloy, something that, until now, only came from human-made industrial processes. Observations from the Hubble Space Telescope and the James Webb Space Telescope have confirmed it. And get this, Atlas is blasting a jet straight toward the sun. That's not supposed to happen with comets, which usually trail away from sunlight. Scientists are losing it over this, sparking a heated debate about where this thing came from and what it's really made of. In July 2025, astronomers spotted 3I/Atlas slicing through our solar system on a wild hyperbolic path, meaning it's not coming back. From the start, it stood out with its massive size, strange chemistry, and bizarre activity. Then in August, the W.M. Keck Observatory dropped a bombshell. Atlas was ejecting around 4 grams of nickel every second, but without a trace of iron. That's unheard of. Normally, comets spew both metals together, since they form side by side in space. Instead, this one was oozing a refined substance called nickel tetracarbonyl, something we've only ever made in labs and high-tech industries like aerospace and metal coating. Finding it out there in the void? That's insane. But that's not the only twist. Atlas doesn't even have the classic glowing tail that comets are famous for. Instead, it's firing off a tight jet that points directly toward the sun. And no, it's not a trick of the light. Multiple instruments have confirmed this freakish orientation. The jet is made mostly of carbon dioxide and water vapor, with small traces of cyanide and nickel compounds. But again, zero iron. The chemistry just doesn't add up. Even stranger, Atlas has an extreme CO2 to H2O ratio of about 8:1, one of the highest ever recorded for an interstellar object. That means its outgassing is totally unbalanced compared to normal comets. On top of that, its surface shows negative polarization, meaning the dust and structure scatter light in a way we've never seen before. The Mars Reconnaissance Orbiter's high-rise camera actually captured images of Atlas during its October flyby, but they're being held back due to the US government shutdown, leaving scientists stuck in suspense, desperate for answers. All these chemical and physical oddities have made 3I/Atlas one of the most closely studied objects in modern astronomy, and one of the most mysterious. The discovery of nickel tetracarbonyl sits at the center of the controversy. This compound just does not form under normal cosmic conditions. Its presence is forcing experts to rewrite what we know about how interstellar bodies evolve chemically over billions of years. Some researchers think Atlas might have formed near a CO2 ice line in its home system, where the mix of iron and nickel was completely different from our solar system. Over time, radiation from deep space could have cooked away certain elements, freeing up nickel gas while trapping iron inside the core. That would make it a natural, but incredibly rare, phenomenon. But then there's Harvard astrophysicist Avi Loeb, who isn't buying that explanation. He's hinting at something far more explosive. Loeb claims that the perfectly aligned sunward jet, the refined metal emissions, and the precise trajectory are just too convenient to be random. According to him, there's a real chance this isn't just another rock drifting through space. It might be something made with intent. Avi Loeb isn't holding back. He's daring to say that this strange alloy might be a technosignature, a literal sign of technology from beyond Earth. That's a huge claim, and it's got the entire scientific world buzzing. But while Loeb's theory sounds straight out of a sci-fi movie, most experts are still cautious. They remind everyone that extraordinary claims need extraordinary proof. Sure, The data is bizarre, but it's not yet conclusive. Right now, multiple research teams are running high-pressure lab experiments, trying to recreate Atlas's emissions under interstellar-like conditions. If natural reactions can't explain this alloy, then things get real interesting. But that's not all. The sunward jet makes the mystery even juicier. Normally, solar wind blasts gas and dust away from the sun, forming that classic comet tail we've all seen. Yet Atlas flips the script. Its material shoots toward the sun. Since this can't be chalked up to a viewing angle trick, scientists are digging deeper into the physics. Could the composition or the size of the dust grains be behind this strange reversal? The data hints at something unusual, possibly ultrafine, compact grains on its surface that scatter sunlight in totally unexpected ways. That could explain why the jet moves opposite to every rule in the Comet playbook. Regardless of what the final verdict is, Atlas has already pushed the limits of what scientists thought was even possible. Whether it's a super rare natural phenomenon or something deliberately engineered, it's forcing astrophysicists to rethink everything they knew about interstellar objects. The discovery isn't just about one rock. It's rewriting how we understand material chemistry across the galaxy. For planetary science, the implications are massive. Atlas proves that not all materials from other star systems follow our familiar blueprints. Finding nickel without iron throws a wrench into every theory about how planets and metals form. If this anomaly checks out, it means some regions of space might have completely different temperature gradients or chemical separation processes than our own solar system. That's groundbreaking stuff. And when you look at the bigger picture, the pattern gets even more fascinating. Every interstellar visitor we've seen acts totally different. One Oumuamua zipped through space without a visible tail, but still changed direction mysteriously, showing weird non-gravitational acceleration. Then came 2 I/Borisov, which looked more like a traditional comet. Now 3 I/Atlas is rewriting the rules again. It's huge, chemically strange, and breaking all the dynamics we thought we understood. Together, these oddballs prove that interstellar space isn't filled with one kind of traveler. It's a wild mix of objects, each carrying the fingerprints of its home system. Atlas has also changed how we hunt these cosmic visitors. Its discovery shows why astronomers must act fast with multi-wavelength follow-ups. Spectroscopy, polarimetry, and high-resolution imaging were key to catching its bizarre traits, and now those tools will be used much earlier in future detections. It's a new playbook for interstellar science. And while the whole techno-signature idea still raises eyebrows, it serves as a powerful reminder: not everything that looks engineered is engineered. Atlas teaches us that nature itself can create signals that seem artificial at first glance. That means scientists need to stay sharp, stay skeptical, but never dismiss the impossible too early. All eyes are now on the upcoming high-rise imagery, which should finally reveal what this alien jet really looks like. Its shape, its brightness, its secrets. Whatever they find, one thing's for sure: Atlas has already made history. The investigation isn't slowing down, it's just getting started. Ongoing observations from Keck, JWST, and a lineup of other powerful telescopes are now zeroing in on 3 I/Atlas, testing which theories actually hold weight. Scientists are closely tracking how the nickel emissions shift as Atlas moves farther from the sun and how that bizarre jet behaves over time. Every new reading could either confirm or crush existing explanations. And right now, the stakes couldn't be higher. Meanwhile, the upcoming Vera C. Rubin Observatory is about to change the game completely. Once it goes fully operational, it'll ramp up the discovery rate of interstellar objects like never before, giving researchers a much bigger sample to compare against Atlas. If this nickel without iron mystery holds up under peer review, It could rewrite sections of astrochemistry and planetary formation theory. Imagine one alien rock forcing scientists to redraw the blueprint of how planets form across the universe. Even if future studies prove Atlas's chemistry is purely natural, it would still represent a jaw-dropping expansion of what we thought was possible for interstellar materials. Either way, it's already a game changer. The 3I/Atlas object has shattered expectations at every turn, from its sunward jet to its industrial-style metal emissions. Nothing about it fits the mold of a typical comet. Whether it's an exotic natural marvel or something far more advanced, Atlas has already earned its place as one of the most important discoveries in modern astronomy. The next wave of observations could do more than solve the mystery. They might redefine what we believe is possible out there in the deep cosmic dark.